welcome to my video. I'm Bing Liu from Chair of Cartography in Technical University of Munich. Today I will present my review work about spatial learning with extended reality. So first I will talk about what is spatial learning and then introduce the XR technology and spatial learning studies. The main part is about conducting spatial learning assessment or the user study. And finally, I will give my conclusion based on the review and our plan for the future work. So space can be divided into small scale or medium scale or large scale space. And in this work, we are talking about the large scale or geospace scale. In the geospace, spatial knowledge are divided into three categories: the landmark, the route, and the survey knowledge. Whether there are still discussions about how these three knowledges are developed, whether they are developed at the same time or they are divided one by one in an order. This landmark, route, and survey knowledge framework is widely accepted and used in this spatial learning researches. In the geospace, it's quite difficult to conduct user studies in the real physical world, as there are many unpredictable factors like the traffic or the weather conditions. So the virtual reality are usually used to build virtual environments as a substitute of the real world. And in this case, the VR is not only limited to HMDs or caves. The virtual environments shown in monitors of PCs are also referred to as virtual reality. And such environments can be buildings or the outdoor parks, squares, or even the whole city. As for augmented reality, they are always used to study the spatial acquisition in real world, or at least in real scenarios. They can be either for the pedestrian or the drivers. And we would like to point out that some augmented reality are actually realized together with virtual reality. For example, the HUD here on the right. And now we come to the spatial learning assessment part, or the user study. First, because the virtual environment is usually created by the researchers, and the users are not familiar with it. There are always or usually a training or learning session. It can be right before the assessment tasks, or weeks or even months before the tasks. And for the user group, the currently most studied user group is the university students, as they are most easily reachable. And for the studies of human development, children and the aged people are of great interest. And finally, as for the sample size, either for the within subject or for the between subject experiment design, usually the minimum sample size should be 20 users per group. There are also many influencing factors that can increase or decrease the user's performance. For example, the spatial ability of the user themselves, or the cognitive workload of the tasks, and the vision or hearing capabilities. There are usually standardized questionnaires or tests to take these factors into consideration. And for a detailed description, please refer to our short paper. For the tasks, they are usually designed to assess the landmark, the route, the survey knowledge separately. And for the landmark knowledge, landmark or scene recognition tasks are usually used. And landmark ordering and route retracing tasks are aimed to test the route knowledge. For the survey knowledge assessment, sketch mapping and spatial term judgment are usually used. Based on our review, we identified some key cognitive issues. The first is the working experience in VR is usually different from what we experience in our daily life, as in VR the users don't need to move a lot. Also in VR with the displays, the depth cues and texture of the buildings are different. Also in many studies, the users complain a lot about the weight or the limited FOVs of the HMDs. And based on our work, we find that XR is widely used in spatial learning studies, and it's possible to combine the tasks to moderate the influences of the identified cognitive issues. But to do that, a systematic review is needed, and that is what we are doing now. That's my work of spatial learning with extended reality. Thank you for your attention.